everyone. So today we're going to be doing a little bit of review on factoring. So this is actually from section 4.3 in the textbook. The rest of this unit, aside from the factoring review, is going to be from a different chapter, but I went ahead and put the section in case you want to look at the book for extra practice. But go ahead and pause this and write this down, and then I will go through it. All right, so first form of factoring that we're going to look at is called the difference of squares. So this is when we have a squared minus b squared. Notice difference means subtraction, so subtraction, and squares means perfect squares. So a perfect square minus a perfect square is equal to a plus b times a minus b. So this is the difference of squares. So it's actually a super nifty trick to know how to do because you can factor it without actually showing any work. So the steps to doing this is factor out any common terms. So if they have a GCF, factor it out. Identify what your A and B values are. Then use your formula. And then check to see if it factors any further. Because sometimes if you do the difference of squares, you're actually left with another thing that you can factor after that, which we'll look at in the examples. All right, so let's go ahead and look at some examples. So we want to factor these completely. First thing I'm going to look at is part A, so 36x to the fourth. This is actually first. There are no common terms, so there's no GCF between 36x to the fourth and negative 49. Zoom this in a little bit. All right, so first off, 36x to the fourth. This is 6x squared squared, which means the 6x squared that's here in the middle, that's the A value. And then the 49, what's the square root of 49? Good, you should have said 7, which means 7 is the B. So when we write out our answer to this, it is just A plus B and then A minus B. So it's literally all I'm going to write. So the A is 6x squared plus 7, and then 6x squared minus 7. And then step 4 is to check to see if it factors any further. These are both two terms, but none of them are perfect squares, so nothing factors any further. So we're done. All right, let's look at part B. Step 1, is there a GCF? So does part B have a GCF? Good, you should have said yes. And your GCF is 2x cubed. So 2x cubed. And then what we're left with is 9x squared minus 25. So this is our GCF. Then from here, I have subtraction, and it's two terms. What is the square root of 9x squared? Good, you should have said 3x. Which means the 3x is our A. And then what's the square root of 25? Good, you should have said 5. Oops, I didn't mean to underline that. Oh well. 5 squared. So 5 is our B. So when we write this out, it's going to be our A plus B. So 3x plus 5. And then A minus B. So 3x minus 5. Are we done? Good, you should have said no. We're missing the 2x cubed. That GCF still has to stay hanging out in front. Can't forget about it. Now you can also do a quick check. Neither of these factor any further. So we're done. Next two examples we're going to look at, part C. This is subtraction. It is two terms, and they are both perfect squares. X to the 6 is a little bit tougher to see that it is a perfect square, but it is. This is x cubed squared, because remember the properties of exponents. When this exponent is raised to a power, you multiply. So this is x cubed times x cubed, which gives us the x to the 6th. But when you look at it right away, you see the number 6, your exponent, and think, well, 6 isn't a perfect square, so x to the 6th isn't. But with exponents and the variables, you always have to be really careful because it's easy to miss those. My b value is 2. So the answer to this will be, good, you should have said x cubed plus 2 and x cubed minus 2. Do either of those factor any further? Good, you should have said no. They do not factor any further. So that's our answer. All right, now for part D, last example on difference of squares. Is there a GCF? Good, you should have said yes. 2 is our GCF. And then we'll be left with 16x to the 4th minus 1. So this was our GCF. Now from here, what is the square root of 16x to the 4th? Good, if you said 4x squared, you are correct. And then what is the square root of 1? Good, if you said 1, you are correct. So this is our A, and this is our B. So we have our GCF, and then 4x squared plus 1, 4x squared minus 1. Do either of those factor any further? If you said yes, you are right. The 4x squared minus 1 is another difference of squares. So this is a difference of squares again. I just drew an actual little square because I didn't have enough room to write the word squares, but you can write the full word out instead of drawing a little square. So we have difference of squares again. So I need to factor this again. How is 4x squared minus 1 going to factor? Good. If you said 2x plus or minus 1, or in other words, 2x plus 1, 2x minus 1, you are correct. So this one is 2x squared and 1 squared. So my final answer, this 2 is out in front. The 4x squared plus 1 still stays there. But then this last factor is 2x plus 1, 2x minus 1. So that's why it's really important to always double check to make sure it doesn't factor any further, because sometimes it can. Next up is review on factoring trinomials. This part I'm going to go a little bit quicker through because this is 100% review from this year. The difference of squares was more so review from previous years. We've seen it a little bit this year, but we haven't explicitly covered it in the notes. Factoring trinomials we have. So this is where we have ax squared plus bx plus c. We do the big X, your a times c goes in the top, and the bottom is your b value, and then you find your factors on the sides. So for the first example, this is when your a value is equal to 1. So in my big X, what's going to go in the top? Good, you should have said negative 20. And what goes in the bottom? You should have said 1. So again, I'll just write this here. A times c and b. What are my two numbers that multiply to get the top and add to get the bottom? You said 5 and negative 4. You are correct. All right, so this is going to be Now notice this is an x to the fourth and an x squared. We're used to seeing x squared and x. So these are going to be x squared plus 5 x squared minus 4. Now this is where we use our knowledge that we just went over of difference of squares. This is the difference of squares. So we can factor this even further. So this is actually x squared, oops, the pen is dying, x squared plus 5. Oh no, hang on, let me get a new pen. The hamburger is not cooperating. All right, we're back. I went ahead and finished writing it since I had to trace over it kind of slowly. You get to use another fun pen. So this one, it looks like a little pill, but when you pull the thing down, it actually rotates it around and it has a different face on both sides. It's sticking its tongue out on that side, and the design on the other side has little eyelashes and little pink cheeks. So now we're done. What we've covered up until this point is you would have just factored it and gotten an answer. Now is the really important part of making sure that you fully factor this, because what we're going to be getting into this unit is something called simplifying rational expressions, which is basically a fraction with all sorts of stuff that looks like this on the top and bottom of the fraction that you have to simplify. And in order to simplify it, you have to be able to fully factor it to see what cancels out. So that's what we're going to be building up to once we get through the review on factoring. What we're going to look at last here is when our a value is not equal to 1, which means it is a positive number that's bigger than 1, or it's a negative number. Now, a reminder with this, always, always, always factor out a GCF or a negative a value first. So if your a value is negative, factor out the negative. And if there's a GCF, always factor that out first. All right, so with this first example, is the a value negative or do we have a GCF? Good, you should have said yes, we have a GCF and it is just x. So I'm going to factor out the x and I'll be left with 2x squared plus 5x plus 3. And now that thing I can factor using the big X. So the top is our a times c and the bottom is b. I'll go ahead and write that again since this is the review. What goes in the top and bottom? Good, you should have said 6 and 5. And then what are my two numbers? Good, you should have said 2 and 3. Now, because our a value is not equal to 1, remember we have to divide these by that a value. So the 2 over 2 simplifies to 1, and then the 3 over 2 does not simplify, so we leave that alone. So my final answer, I have the GCF out in front, so x, and then this positive 1 gives me the factor x plus 1, and then this 3 over 2 gives me 2x plus 3. Does anything factor further? You should have said no. We don't have any difference of squares. Nothing can be factored any further. So we're done. Last example of the day. What do I need to do first? You should have said factor out the negative a value and the GCF, or some other way of saying that same thing in other words. So negative 3, because the negative always has to get factored out, and then 3 is also a GCF. So we'll be left with x squared minus 13x plus 36, because all of our signs will flip. And then, scoot that down a little bit. And then we do our big X. So the top will be our a times c, the bottom is our b. So what goes in the top and bottom? Good, you should have said 36 and negative 13. What are my two numbers? You should have said negative 9 and negative 4. Now our a value is equal to 1, so I don't need to do anything else. So now what I'm going to have, negative 3, my GCF written out in front, x minus 9, x minus 4. Does anything factor further? You should have said no. Now, if we had started out, if this was an x to the 4th and x squared, these would have ended up being x squared minus 9 and x squared minus 4. Both of those would be a difference of squares that can factor further. So you'd have to do one more step to get your final answer. Alrighty, that is the end of our notes. Have a good rest of your day.